Atlas allows you to automate these processes. So if you do something manually, if you work with your imagery manually and you need to generate some reports and find some things on this imagery, then you can try Atlas. In which areas you can use Atlas? Very, very different. And everywhere where you get aerial photography, just a raw imagery, or you need to work with orthomosaics, you can benefit from Atlas. And these are only several examples where Atlas can be used. This example is provided by our clients. So you can use it for road quality detection, for sure. You can count things like ships and boats on the sea. If you have some specific data sets, for example, imagery from the ultraviolet camera with corona discharge indications, then you also can use Atlas to select images which contain these corona indicators. Also, you can use Atlas to work with imagery from different urban areas and for planning a few activities in civil engineering areas, like work with cars, taxis, vans, count buses, etc. Again, you can use it, for example, to detect road marking and signs. And also you can detect complex things like vegetation areas with complex shapes, water resources, or, for example, solar panels. These are only a few examples. So if you think something in mind, just don't hesitate. Drop a line in our Q&A section if you have some area that you want to discuss more on this webinar. Just send a message. We'll try to touch it at the very end of the webinar. So again, just to summarize, what can be processed with Atlas? You can feed raw imagery, JPG or PNG files that you get directly from your drone or, I don't know, from your handheld camera. That's what you can upload to Atlas, store and process. And you also can work with orthomosaics. So in Atlas, we have a photogrammetry processor embedded, but if you don't like it, you can always take orthomosaics from your favorite photogrammetry tool, like, I don't know, Pix4D Metashape or anything you like, get this product and upload to Atlas. And your main algorithm of working in Atlas is pretty simple. So if you want to build your own detector for some object, you need to do three things. First of all, of course, you need to annotate a small fraction of data manually, just to tell to the our machine learning algorithms what you want to what you look for. Then you make training with Atlas, and I will show you how you can make it. It's pretty easy, just a matter of clicking a couple of button clicks. And after training, you get your first result. Atlas will generate you automatic annotation. If you're not satisfied with this annotation, you can repeat this process. Correct your initial annotation and then train it one more time. So pretty simple. Now let's switch to demo. Okay, So I hope you can see application window.
Yes.
Okay, perfect. So Atlas is a web-based platform. First of all, it allows you to structure your imagery data properly. You can organize your data into projects, and on this level, you can see several projects in my workspace. And also, inside the project, you can have multiple data sets. And depending on your main workflow, operation workflow, the meaning of these levels can be very different, but as a very common example, I can tell you that, for example, if you need to make regular photography of the same place, then this one place can give a name to your project, and each survey, for example, weekly survey, can be stored in separate data set. So let's go to some examples. I will show you the data set with a map, QWERTY mosaics. And here you can see two types of objects, two types of annotations, cars and vegetations. And I'm going to explain what's new appeared in our latest versions. So for those who are already familiar with our software, that will be useful. For those who are not familiar, just see what Atlas can do for you. So first of all, again, to support our main workflow, annotate manually, train your detector, and get the result. These three main steps. So first of all, Atlas provides you with tools to make your manual annotation. We have several tools to annotate objects of interest. There are also two figures that can be used to annotate background, because it is very important for the artificial intelligence to know what is the object of interest and what is the background, properly distinguish these two types of these two entities. So let's, for example, check cars. So if I will expand the car label, which is on the right side of the screen, you will see two main blocks, manual annotations and detected objects. So first of all, I will show how manual annotation looks like. So if we want to detect cars, then we need to add, just to define several figures for existing cars. And here I used a polygon tool to manually add these figures around several cars on the street. I also had to specify to the neural network what is the background, and this dashed red line defines the background area. And after that, and basically, I can repeat this manual annotation several times if I'm not satisfied with detection result. But like when you, even if you annotate this small amount of objects, even now you can make your first training. To make a training, you need just to press the train button. And after that, the system will prompt you whether you want to create a new detector from scratch or you already have existing detectors that you want to improve. If you create new, then what you need to do to select object for training and detector name. After that, you press the train one more time and training starts. Typically, in our cloud-based solution, the training takes from 15 minutes to 1 hour, depending on the area size, on the amount of annotation. But after that, you get a notification by email, so you don't need to sit in front of your screen and wait when the process will end. So you will get a notification, so you can do other things, and even you can switch to other data sets in Atlas and work with the data. So after training, you will get first results. And I'm not going to run training right now. I will show you these results. Here you can see the results of the automatic detection. So these figures were generated by the system. And another thing that I want to explain you is something that we added recently, and this was something that we received as requests from our existing clients. So just look at this white area. It is this area, we call it working area, meaning that when you run detection process, you can either select, either choose detection on the entire map, or you can specify that detection should be run only inside the working area. That is a very efficient tool because it allows you to, first of all, to speed up the detection process significantly. Also, if you are not sure that the detection will be very accurate at the beginning of your training process, then again you will using working areas, you will receive results faster, you will spend less megapixels for detection, and you will be able also to add additional knowledge to the detection process, because, for example, in certain cases, you know for sure that a certain type of object cannot appear in a certain area. For example, car, it is very low probability that you will, for example, if you want to detect cars, for example, you will find a car in the sea, yeah, if you have a bay area, yeah, and the same thing about other types of objects. So with working areas, you can limit the territory where your detection will be executed. And also, for example, if you want to check only specific areas, like you want to know how many cars are on a certain parking areas, you can annotate this parking areas, specify working areas there, and you will get car count only for those areas. So for example, in this data set, we have 3 parking areas. And this is the first one, and that's the second, and that's the third. So all the detections happen only, automatic detections happen only within these working areas. And for each working area, you can see the statistics, how many cars are inside this area. And also, for each area, you can download the detection results as a GeoJSON. So, for example, if you need to analyze this data in external systems, in external GIS systems, or computer-aided design system, you can always export your detection results and use them in third-party solutions. So, what else is important? I want to point your attention that for each orthomosaics, we have information. So for each orthomosaics, you know how many hectares it occupies, what is the ground sampling distance, what is the use space in megabytes or gigabytes, and also what is the size in megapixels. This information is useful during processing, and also you can that can be useful for some other reporting tasks. Also, for the same area, you can have multiple object types. And here we have two object types, cars and vegetation. And vegetation is just another type of object. It has a very complex shape. Car is typically convex in geometrical sense. Vegetation is not convex, and it can be of a very, very different shape, but our machine learning algorithm, it can detect also such complex objects. And again, about the process, it is absolutely the same. If you want to detect vegetation, again, you need to provide some manual annotation at the very beginning, and this is what I annotated manually. So I added a couple of figures denoting trees, and also with this rectangle, I specified the background, and then I trained my model. So the process is absolutely the same. All those three steps: annotate manually, train, and get your first results. And this is how the results look like. And for each area you see in the hint, you always see the label type. In this case, it's the vegetation, and also you see the area size. So now it's like 1,900 square meters. And again, for all the detection results, you can always download these results as GeoJSON. Later, we will add support for other file formats like shape and DXF. For now, it's only GeoJSON, but as far as I know, GeoJSON is supported by all the popular GIS systems like QuantumGIS, like ArcGIS, and others. So it can be used widely. So let's switch to another case. So I will show you another data set. And we will continue our continue speaking about civil engineering analysis. Now I'm going to show you an example how you can get a road quality report. This is a data set provided and actually processed by one of our clients. And his goal was to detect areas on the asphalt surface which are not good, which can be repaired. And that's what we got as a result. So I will zoom as much as I can. And actually the ground sampling distance for these specific orthomosaics is quite good. So it's around 2 centimeters. So I will disable labels, and as you can see, I hope you can see that this part of the road is not very good and it can be repaired. And I'm switching back the detection results, and as you can see, the detection is quite accurate. But again, these detection results, they can be exported, but also, as you can see, there are many small pieces that might be not interested for your client. Maybe they just want to know about big areas which can be repaired, and they are not interested in very small areas which can be left untouched. So what you can do here, and we analyzed what we can do here to make the process as fast as possible to our clients and not to force them to reprocess imagery in our client and thus spend additional megapixels, and decided to implement a filtering option here. So what we have? So you have two options. First of all, we can filter detection results by confidence. Confidence is a probability which assigned by the neural network to the figure, and it specifies how confident neural network in the result. So for example, if I will show results which which have a high confidence level, and will apply this filter, that you will see that some results disappear. I will show it one more time, so I will disable it. Yeah, you see a lot of small things that might be not interesting to the end user. So if we increase the quality of the detection without any additional processing, just we apply this filter, then some results that might be just junk, these results disappear. That's one thing that you can do, and which easily can save a lot of time for you. And another thing that can be useful for you is filtering by the object size. For example, you can get from your client the requirement that they want to receive information only about defects on the road, which are bigger than, I don't know, 7 square meters. And let's apply this filter. And as you can see, another part of results disappeared. So we can increase it, for example, for 10. And now we have only, you can see in this detection section, you can see that there are only 3 objects detected. So you removed a lot of junk from your result set. And now you can export the resulting data set and provide it as a report. Then the road maintenance team can take these results and actually approach identified locations and make a decision whether it's worth to make any repair there or not. And another example that I want to show you is, again, it's a real-life example. It's from agriculture. So I will show you 2 fields. We will start from a very interesting case from our client from Israel. So they made an aerial photography of the field, and their task was to identify the weed on this field. There is such a thing which is called field dodder. It's quite invasive weed, and it's very important not to allow to spread this weed across the field, and identify it at an early stage. So again, I will disable annotation so you could see these yellow areas on the field, and these yellow areas denote the read. The green areas are healthy areas. So our goal was to identify accurately these yellow areas. And then, again, this detection result can be used to minimize the spread of this weed. So, again, the principles were absolutely the same as I already demonstrated to you. So we made several manual annotations. So we defined for the future training what is object of interest. The solid lines define, solid blue lines define object of interest, and dashed lines define the background. And then after training, we got this result. And these results were exported again as a GeoJSON, and they were transferred to this GIS system where were analyzed by the field owner. Actually, for other types of diseases, this vector layer can be used, for example, to as a like a flight plan for the automatic steering system installed on the tractor. And we have such examples when people use detection results as a flight plan for the tractor. So also for each label, if you have many labels, many object types on in your area, you can always specify a unique color for each object type. And these settings are memorized for entire data set, so you can always share these results with other participants of this project. And the last example that I want to show you, it's again from the agricultural area. It's a big field of almond trees, and with Atlas we identified the top parts of the trees and use this for tree counting. And as a source material, we used rendered multispectral imagery, because you may notice this very special coloring. So yeah, and as you can see, almost for every tree we have a red point. And again, if you want to calculate only trees in a certain sector of the field, you always can use working area and see the statistics for this specific working area. Basically, that's it. With demonstration, I want to shortly return back to my presentation, and then we will we'll go instantly to the questions and answers. So yeah, that's an important question that we receive from time to time, and I want again to explain how we sell this solution. It's available as a cloud-based solution, and if you are okay with uploading your data to cloud and you don't want to set up any on-premises installation, then you can visit our website and go to pricing section and select the price plan that perfectly fits your needs. And also for we have a 14-day free trial, so you can test system without paying anything. But we also see another demand from large organizations, from governmental customers. So we see that our clients also want, in some cases, they don't want to send their data to some cloud. Even if it is a secured cloud and very well protected, but they want to have everything on premises. And we provide such an option. So what is important to understand? So all the functionalities that you see in our cloud can be deployed in your data center. Of course, we agree on pricing on a case-by-case approach. But if you are interested in such on-premises solution, you definitely need to contact our sales and explain the approximate amount of data that you want to store in the system, the number of users that you want to have in the system, and then we will get back to you with a proposal. So before Q&A, I just one more time want to show you that on our website, recently we introduced a new section, Learn, where you can find a getting started tutorial. It consists now of 10 lessons, but it introduces all the basic and most important concepts: how to upload data to the system, how to properly structure it, how to annotate it, how to train your detector for raw imagery or for orthomosaics. So this should be definitely as a starting point for you if you have any questions. But of course, as for any other our projects and products, we do have support line, so you can always drop us a message and we will help you with any of your questions. Okay, so let's walk through the Q&A. Okay, good. So we have 8 questions, and I will just go one by one. So the first question is from Hermanos. Will it be possible to identify manholes and power lines on roads? Yes, it is possible. Because manholes is like it's a very good object for such system. Power lines also depending on what you want to detect. So if you want to detect the pillar or tower itself, definitely possible. If you want to identify, for example, insulator, it's possible. If you want to identify wire, it can be a bit more complicated and depends a lot on the resolution of your imagery. So, but general answer is yes, and you always can try, you can upload your sample data to our system and try it. The question from Scott: can this work for orthomosaics in a local or a custom coordinate system? For now, we do not support local or custom coordinate systems. So we work in a global coordinate system, but you always can reach. But again, this topic is typically not that straightforward. So we are very open to such conversations. So please, if you are not sure will your data work in our system, just drop us a message to our support and give us several examples of your coordinate systems or projections that you want to use, and we will give you an answer. The question from Alvin: where will the recording be available? I think the question is about the recording of this webinar. If that's the case, then we will, as usual, we will publish a recording of this webinar on our YouTube channel, and for all participants, we will send a link. So, yeah. Oh, great question from Manfred. The Atlas software is only in English available. Actually, in 2 weeks, we will add to Atlas other languages. So Atlas is prepared for other languages. So in 2 weeks, Spanish will appear in Atlas, and also Chinese. If you need other languages, please drop us a line. So actually, you can post if you are expecting some language, you can post right now in this Q&A, and we will process it later. So yeah, Atlas will support multiple languages shortly. Hi. Okay, question from Ricardo. Hi, what is the GSD of the survey? If you mean what was the GSD of the examples that I've shown to you, the GSD was very different, and we can check it together. So, for example, for this agricultural field, you can see that GSD is around 1.5 centimeters. For example, for our first project, the GSD is around 7 centimeters. So it's a very good question, because for machine learning and for many objects, you don't need to have an extremely high resolution, extremely low GSD. So 7, 10, 15 centimeters, depending on the object size. So this low resolution can be also okay. Basically, the rule of thumb is if you can distinguish your object with your eyes, then most probably algorithm will also be able to identify such object. The question from anonymous attendee: can it be used for active detection of for active detection of drones? I think no. If you are thinking about the drone detection system that will intercept in real time the drone while it's approaching some location, no, the system is slightly different. So I think here the answer is no. We definitely can detect everything that captured as imagery or orthomosaics. Later, we will introduce some detection capabilities for video, but I'm not sure that for drone detection it's a good solution. There are other solutions on the market. So next, the question from Trevor: can I detect geological features, minerals, and rock colors if they are similar? Yes, you can. And actually, we have a very interesting example of using Atlas. Shortly we will publish it as a use case. But in short, we have clients who used not the camera, but they used other sensors like echo sounder to acquire data, and then they generated a geotiff out of this data. uploaded to Atlas and detected objects on this GeoTIFF. But if your minerals or rocks, if you capture them with a normal camera, and again, the level of generalization for such objects is quite high, they have different colors, then yes, definitely you can upload your data to Atlas and try to detect, to make this, I don't know, either to detect them as a small simple objects or make a territory segmentation similar to what I've shown in case of vegetation. Yeah. The question again from anonymous attendee, does it work for DJI drones? If you mean that does it work for data acquired with DJI cameras, yes, of course. It perfectly works with data acquired by DJI cameras. A question from team, can digital elevation model and point clouds be utilized for height? Again, very nice question, and I can unveil a little bit our roadmap, because again, shortly, in very few weeks, we will add support also for elevation models, so you will be able to upload elevation on a 2D map and see the heat map of your elevation. Also make filtering by height, and also combine the results of automatic detection on imagery with your elevation model, for example, to eliminate from your elevation model some artificial objects. For example, I don't know, you have a heap of sand and you have an excavator on top of this heap, and you want to remove excavator from your elevation model. That's what you will be able to do with Atlas shortly. Another question from team, measurements. Yeah, as you can see, we can show the area size of the detected figure. Later, we will add more measurement tools for linear measurements and measurement heights. Yeah, we will when we will add support for elevation, you will be able to see the height values for certain points, if you mean that. Okay, I see no more questions. Okay, thank you, team. I also like this feature, actually. We also have it in our development environment. Actually, can't wait to make it public. Okay, thank you very much. So if you have any other questions, so actually send them like in a minute, or we can wrap up for today. So I hope you found something useful for your business. And yeah,